I want to jump into this topic of the hot sedimentary aquifer. So this is the next generation type of geothermal.
If you drill down anywhere in the earth, it's going to get hotter. But if you go after these in place fluids, water has a much larger energy content than rock. So there's a lot more energy there, and it'll last longer. And if you harvest it well, it allows you to make very cost-effective power. So a single well pair, depending on the thickness of the aquifer, the permeability, and the temperature and stuff, will yield in the DJ Basin about 5 megawatts gross.
Yeah.
So at the end of the day, it comes down to cost. Now, the good news is we think that we can compete with solar and wind and even hydrocarbons.
So welcome to Geothermal Unleashed, where we will explore the cutting edge of geothermal energy. I'm Elizabeth Cambre from the Vallourec New Energies team, and I'm here to help educate and document geothermal's rise in the global energy transition. And I want to give a special thanks to Think Geo Energy. So joining me today is Jim Hollis, the COO of Geothermal Technologies. So today we're going to talk about his startup company, Geothermal Technologies, and we're going to talk about their next generation geothermal solution that is called Hot Sedimentary Aquifers, if I got that correct, Jim.
You
So
sure did.
great. So I want to welcome Jim to the podcast. And I want to start by asking you first, Jim, to share some details on your background and explain how you got involved in geothermal and how did geothermal technologies come about?
Thank you. Yeah, happy to. So I'm a exploration geophysicist, and I started out looking for oil and gas, working for Mobile, and then to more of the field services where I worked for different folks in the software business, size of business. About 10 years ago, I got very involved in machine learning, and I was doing a startup where we were blending different data layers of gravity, magnetic, whatever, from looking at the subsurface. And I started to think about geothermal. And about that time, I was contacted by the technology ventures arm of Johns Hopkins. And they had some really neat, new, innovative geothermal tools that they wanted to commercialize. And would I be interested in doing that? So about 6 years ago, we started up GTI, and we've been working hard at it ever since.
Okay, awesome. So, I've got a lot of questions, but I want to jump into this topic of the hot sedimentary aquifer. So this is the next generation type of geothermal that Geothermal Technologies is going after. So how did how did you start looking at this type of next generation geothermal?
Yeah, so it actually came from thinking really hard about, how do we scale geothermal from the conventional world, which is fantastic. I mean, uh, the work that's being done now in exploiting conventional systems is amazing. They're super complicated, but the problem is that they're not that common, right? So what you need is a very unique geologic environment where you might have a volcano or a plate boundary or something like that. So how do we scale geothermal beyond that? And the bottom line is that we're living on a giant battery. The Earth's center is hotter than the face of the sun. And how do we tap into that power, which is carbon free, it's base load, and it's not cooling off, right? So we thought long and hard about it, and we thought about um, uh, what was the best way to cost effectively bring that energy up.
Sure.
And we ended up focusing on the hot waters that exist at the bottom of oil and gas basins. So down at the bottom, below the oil and gas window, there's this briny water that sits down there. It's been soaking up energy for years and years and years and years. And if we could harvest that in a pragmatic way and really focus on longevity, all of a sudden we're making power, not geothermal everywhere, but a lot of places where we have tons of infrastructure and the sort of things that we need to make things happen quickly. So that's how we got involved with HSAs.
Okay, so let's talk about HSAs and how they differ from other types of next generation geothermal. So can you explain how this differs from, say, what some of the other startup companies are doing in enhanced geothermal systems? So what are the key differences?
Yeah. So I think the biggest one is that we're going after fluid that's in place. So a lot of the recent advancements in these manufactured systems or engineered systems is that they end up drilling into hot rock, which is usually basement rock. So think of it as very non-porous, right? And so they have to engineer not only the plumbing system of getting the water down there and bringing it back up, but they have to engineer the reservoir, right? And so what we're doing is we're borrowing a lot of technologies and thinking from the conventional exploration for hydrocarbons and saying, let's go find a reservoir of hot water that's down there. So we don't need to engineer that reservoir. We do engineer the plumbing system. And what's neat about that is that we found that if we use things like lateral drilling and the completion technologies that have been developed in the recent future, we can build these systems so they last a really long time. And that longevity, which is what we're super focused on, if you can depreciate the cost of building these over 10, 20, 30 years before that system will cool off, all of a sudden you've got cheap, affordable baseload carbon-free power. And so the big difference is, in our mind, is really focusing on longevity versus being able to build one of these systems anywhere. Because if you drill down anywhere in the earth, it's going to get hotter, right?
Yes.
But if you go after these in place fluids, water has a much larger energy content than rock. So there's a lot more energy there and it'll last longer. And if you harvest it well, it allows you to make very cost effective power.
Okay, so let me ask a few questions.
Sure.
So in an HSA type of system, do you have to frack these reservoirs?
Great question. And eventually, probably so.
Okay.
But right now, using things like 3D seismic and a lot of the wells that have been drilled, mostly for wastewater injection, right? So we're down below the hydrocarbon window, and we're actually not going for geologic highs, we're going for geologic lows. So there's not a lot of wells drilled there, but using the wells that we do have and the seismic data, we're finding a permeability, which is the key factor. You know, how much. So one thing that I haven't mentioned is that these geothermal reservoirs are a little bit cooler than what you might get in a hot, dry rock
Okay.
sort of situation. So we're looking at somewhere between 125 and 150 C.
Okay.
And to make power with that sort of water, we need a couple of things. One is that we need extremely high flow rates. And to get extremely high flow rates, you need a lateral well that's fairly big, and you need rock that has the permeability that allow you to flow that water that quick. So we can go and use a lot of the existing multi-client 3D seismic data and well logs and find permeability that doesn't need to be fracked. Now, that's not to say that when we step out and expand these things, we're going to get into tighter and tighter rock, and we may have to frack it in the future. But right now, there appears to be a lot of low-hanging fruit out there that we can exploit now.
So are you going after oil and gas wells that are already drilled and completed and then just drilling deeper so you can target these zones that have the hot aquifers, or are you drilling new wells?
Great question. Yeah, so we looked at using the existing wells, which would be great, but unfortunately, you can't get the flow rates that you need because the diameter of those wells is too small. I mean, they've been drilled for something else, and they've also haven't been drilled in the configuration that we need. So at the basis of the technology that we have at the company is this idea that we can drill lateral wells into the aquifer and have the geometry of those right and the pressure right that we induce a convective recharge field that brings hot water from further out. And that's one of the tricks that we use to make sure that these things last for decades and don't cool off. So that is a very unique sort of situation where you need big diameters, you need a certain length of the lateral, you need a distance spacing it that kicks off basically a dipole field. And all of those things mean that you can't really use the wells that have already been drilled, except for the data. There is just
Yeah,
billions and billions of dollars worth of data that we can leverage to find these sweet spots.
right.
And we can use infrastructure in the oil field. I mean, why not use a pad that's already been made? The roads, the electrical, I mean, everything that's in an oil field, we can reuse, but we're going to have to drill new wells.
Yeah. Yeah, that's very interesting. And so the whole longevity piece is critical when it comes to geothermal in order to get your cost down and to be able to compete with other renewables. So what is the longevity that you're targeting for your wells? And I'm very curious. Can you share any details of power out
Yeah. So,
targeting?
so it depends a lot on a couple of things. You know, one is the temperature of the water, right? Because that then leads to what sort of flow rates that we need. So the faster the flow rate, the faster we harvest the energy that's there. And then other factors include the permeability and the thickness of the aquifer. And so all of those kind of play into a factor. So we optimize um, how we build these systems in the subsurface. But we're looking at a lot of our reservoir models that we've been running last for 30 years, right? And that's without having to drill new wells. And so that's what we've been doing. Now we can optimize for other things like cost and because that's like the length of the lateral and things like that. But when you optimize for longevity, it all kind of comes out in the wash because you can depreciate maybe a little bit additional cost of drilling a longer lateral over longer, which brings the cost way down.
Yes. Okay. And then what does the temperature decline? Can you share any details of what you're modeling and what you think how that's going to compare to, say, an enhanced geothermal system?
Yeah, so we're not experts on the hot dry rock, and we've run and built some models just to get an idea, but we don't see any significant thermal decline for, like I said, 25 to 30 years. So, and it's just because we're using convection to transfer the heat, and the water has a lot more energy in it. So we're not seeing the issues that you might get with having to depend on conduction,
Sure.
meaning that you drill into hot dry rock, you pour cold water on the hot rock, it warms the water up, you produce it, but you're cooling that rock off, right? And conduction isn't as efficient as a convection in transferring heat. So
Okay.
that's our big focus is let's go after these aquifers, not drinking water. I mean, they're very briny, but that have been soaking up heat for years and years and years and years, and there's a lot of it. I mean, working as an oil and gas explorationist, we've tried to stay away from that hot water, right?
Right.
Um, so,
Okay.
but that's the trick. Now it's not geothermal anywhere, but if you look at a map of say the U.S. and all the oil and gas basins, and you can look at maybe where the shale plays are, right? We've looked at a lot of those basins, and they all have these sweet spots that has the right temperature and the permeability and the depth that we think this is very viable.
So can you share regionally where you're looking at to develop geothermal?
Yeah.
Okay.
Yes. So we started out in the Denver Basin, and we really like it. It's very well behaved. There's lots and lots of data. There's lots of wells from the conventional oil and gas, and then the shale play, the Niobrara there, and wastewater in injection, and lots of 3D seismic. So it's very, very, very data rich. And beyond that, we've been looking at a aquifer that's down about 9,000 feet, and it's about I'm going to mix my units here. I'm sorry, but it's
Okay.
about 30 meters thick, and it's about 125 to 135 C. So it's plenty warm. Um,
And
and
that's in Colorado as well.
Yeah. It's um the first spot that we've been looking at is like due east to Fort Collins in the Greeley area.
Okay.
Yeah.
Okay. So do you think you're going to focus predominantly then in the Colorado region for your geothermal projects?
Oh no, that's just where we're starting. So we've
Okay.
been looking at the Williston Basin. We've been looking in Colorado again at the San Juan Basin, the Piceance Basin, the Raton Basin, the Appalachian Basin. There's just what you kind of need is you need a stack of sediments, and then you need a geothermal gradient that's deep enough that you can still be within the sediments when you get to the temperature that you want. And then you go looking for a some sort of reservoir, as you would for conventional oil, right? And that's got the permeability that you need, the the, the thickness, and that's what you target. So we're looking at lots of different basins, not only in the U.S. but overseas
Okay.
as well.
Okay, so let me see if I can summarize all of the advantages or benefits of HSA geothermal. So you don't necessarily have to fracture. You're going after areas where you've got the permeability and you've got existing hot aquifers. You've got a lot of data that's available. You could have longevity of your thermal stability because you've got the presence of convection. And what else? So you don't have to have a large amount of water like you would in other EGS types of systems.
Yeah,
So
we don't use water,
you
right? I
don't use
mean,
water.
we pull it up, we take the energy out of it, and we put it back down, right?
Okay.
So there's a net zero water use.
Okay. So those are some great advantages, and I may have missed some, and you can highlight if I missed some. But what are some of the challenges?
Aha. Nothing's easy, right?
Yeah.
I guess before I go there,
Yeah.
uh, there's a really good question is kind of why now?
Okay.
I mean, these hot waters have been around forever, we know about. And there's kind of like three things that really kind of play into why this is very viable now. One is lateral drilling. A lot of the early exploitation of HSAs, they tried it with vertical wells, and you couldn't really get the flow rates, and you gum up the permeability. But by being able to drill fairly inexpensive lateral wells, um, really check the box on making this work, right? And the second thing is all that data, right? So the ability to use cloud and upload all these and build very sophisticated report models that you can then use to reduce the uncertainty and optimize all the parameters of how you build these things is big. Before the cloud, a startup like ours wouldn't have the compute necessary to do that sort of thing. And the third thing, and probably most important, are these binary cycle geothermal plants. So the ability to make power using something like organic Rankine systems and make power from cooler water is key. So all three of those things kind of happened at the same time. Uh, so answering the question now, what are the challenges? Um, our biggest risk is being able to quantify the uncertainty on the permeability.
Okay.
So So it's technical, and we've got lots of ways that we can do it using well logs and using both the pre-stack and post-stack seismic data. We've looked at passive seismic. So there's lots of interesting things. Fiber optics, we have some specialists there that are going to help us understand once we drill these things, what's going on with the flow field and all these things. But it's very sophisticated reservoir management, which is something that the oil and gas folks have gotten really, really good at. And so we're harnessing a bunch of that. But the biggest risk is the permeability. And then how do you mitigate it? Well, you brought that up. Maybe you have to frack, right?
Sure.
But right now, everything we're seeing suggests that that's something that we probably don't have to do.
Okay. So what about the water chemistry? What is that like? Does that pose any additional challenges to the overall system? Do you have a lot of corrosivity? Have you already analyzed some of the water in the aquifers that you're targeting?
Yeah, so for this area in the DJ Basin, luckily we actually have samples from the wastewater wells that have been drilled. And the chemistry is important because it helps you figure out how much power that you can generate, issues with scaling. But that water has been sitting down there for a long time, and um, it's not like you're introducing water into a new environment. So it's well known and it's behaved. So we don't plan on flashing. We're just going to bring the water up, put it through a heat exchanger, and then back down in. And then we're going to look after the normal scaling that you might get by doing that sort of thing. But we don't think that it's a big thing.
Okay.
Now, with that said, some of the basins that we're looking at have potential for things like lithium, right? So being able to maybe co-produce and bring up lithium, run that through some filters and bring that out, and also generate power would be fairly neat. But as a startup, we're focused right now
Yeah.
on power,
I mean, have
right?
you looked at what your lithium concentrations might be in the
We
region?
have,
And is there lithium?
yes,
No, that's
yeah,
exciting to hear. Okay.
yeah, and not a whole lot, but at these flow rates that we're looking at, and
Okay.
the flow rates that we're looking at are like 100 liters a second, right? So this is a little bit higher flow rates than you would have in the oil and gas business, right?
Right.
But not uncommon in the conventional geothermal world, right?
Okay.
Um,
Okay. So let's see. Let's talk a little bit about permitting. I've heard you talk about this in Colorado, and I know it's a little bit complex. So can you speak to this?
yeah, so Colorado's been great. I mean, we started out trying to get a permit, and at the time the rules were basically you get the permit through the folks that manage water wells, right? And the more that we kind of spoke about what we wanted to do, it sounded more and more like oil and gas
Sure.
because they had permits for folks who wanted to bring the water up and use it, or they had ones that if you wanted to inject something, but they didn't have a category for bringing the water up, getting the energy out, and putting it back in. So there was no net water use, and so that we had to actually kind of build new rules. And so about midway through the process, Colorado basically changed and moved the requirement for getting the permit over to the group that had been doing oil and gas. And they were able to take a bunch of their learnings on how to do that safely and superimpose those on there. So we worked with them in helping to set those up. But it's an interesting. It actually borrows more from oil and gas than from drilling wells for watering your fields or injecting wastewaters, things
Yeah,
like
that's
that.
pretty
So,
interesting. So, okay, what is your timeline for your first geothermal project, and what have been the biggest challenges in getting your projects off the ground?
so great question. As a bunch of scientists, of course, we've been focused on the technical stuff,
Yeah.
because those are things that we solve. But at the end of the day, it's commercial and it's being able to raise the capital. So we are engaged now with several folks to basically on-sell the power. So to get a PPA. And some of the people that we're speaking with um, run the power grids there, and they're very interested in having baseload carbon-free power and to basically add in and help out the stabilizing their grid, and it helps them going toward their net zero goals and all that. But we're also talking to folks who are interested in using the power behind the meter.
Oh,
Um,
okay.
and these are folks that are looking at things like data centers,
So,
whether they're mining Bitcoins or doing AI, but there's a lot of need for power and a lot of folks who are interested in reducing their carbon footprint. So, but what's hard is even though we're using a lot of mature technologies like lateral drilling and we forward modeling of the reservoir and things like that, there's still risk and nobody wants to really do the first one,
no, I
right? So
understand.
that's been the hardest.
So you brought up a few things, and I want you to backtrack a little bit because I don't know
Okay.
if everybody knows what behind the meter is. So if you could explain that, and then I'm really curious, in Colorado, do they have policies that support behind the meter?
So behind the meter means that you don't go to the grid, right? So if you have, say, a dairy farm, or if you have a data center, you can just use, say you have a solar field or windmill or something, you can just use the power without going to the grid. As far as I understand today, Colorado is okay with that,
Okay.
right? Now, this is everything's moving, right? So,
Right.
but we're happy actually to be probably connecting with the grid and then working with them to help provide the power, however that they want to, because they're experts. I mean,
Right.
we're geophysicists and and geologists, and so we're good at getting the energy, but how that's used be, beyond that, we're not experts in.
So, it's fair enough.
Yeah.
So I'm just curious, what is the experience like when you're trying to go and get PPA signed? Do you have to do a lot of convincing that geothermal is the right solution, or has the industry kind of recognized that and they see geothermal as a potential solution, and they're more coming to you needing a solution for clean, reliable baseload power?
That's a great question. And what we've experienced is it's a mixture of both.
Okay.
And if you start bringing geothermal into places where it hasn't been used ever, like Colorado, then the grid operators are not as familiar with it. Right now, if you're trying to do it in California or Nevada, that's a whole different world. So part of it is educating, and then a part of it also is the cost, right? At the end of the day, there doesn't appear to be a additional benefit that you can negotiate with, that it's not only green baseload, well, green power, but it's baseline. So it should go up against solar plus storage, right?
Sure.
When you're looking at the value of it.
Yeah.
So at the end of the day, it comes down to cost. Now, the good news is we think that we can compete with solar and wind and even hydrocarbons because of the longevity that we get. So we're going down that path, right?
Yeah.
But at the end of the day, if you can't point to a plant that's been running for 30 years and say, look, we've proved this will run for 30 years, there's a leap of faith. Now, in the oil and gas business, we look at uncertainties all the time and we manage those, right? And so it's kind of a meeting of how oil and gas folks think about risk and the the actual grid, right? And the folks who supply power. So it's a interesting kind of new space.
Yeah. I just find the geothermal space so fascinating. There's so many startups, and it seems as though every startup has their own approach to geothermal, and it's so interesting to see everyone spin. Is Geothermal Technologies Inc. the only company out there pursuing these hot sedimentary aquifers? And I mean, did you
Yeah.
guys come up with this term? Are you responsible for coining the term HSA?
No, actually, it's been around for a long time. Um, the the earlier attempts at it that I've looked at actually were in the Cooper Basin,
Okay.
and there was some attempt to drill into these aquifers and make power. And again, they used vertical well and didn't really get the performance and the flow rates, right? But it's been around for a while. There's a company up in Saskatchewan
Okay.
called Deep,
I
and
know.
they are also going after
Correct.
an HSA. The term HSA didn't exist really, so we've been helping to kind of put a name on it. There's also a company up in, I think, Alberta
Uh-huh.
that's um, they have I think it was a gas field that watered out, but it watered out with hot water. So they
Yeah.
converted the field into a geothermal plant, and they're flowing multiple wells into a single pipe so they can get the flow rates that they need. And then they're using the little bit of gas that's still left to increase the
Interesting.
temperature,
Oh,
and they're
interesting.
making power. I think the name of the company is Futera,
Oh, I haven't heard of them.
but that's
Okay.
fascinating. And so
Yeah.
there's other people in Canada and Australia who are looking at these aquifers, and then of course in Europe, a lot of these aquifers are used for direct use. Uh,
Yes. Yeah.
but
Okay.
I think we're one of few who are looking at, how do we make power?
How to make power. So then, can you share any details on the amount of power you anticipate you're going to get from a single well?
So our systems are actually well pairs.
Okay.
There's a uh, there's the production well that goes the injectable well, and gotta have a pair because it's the interaction between those wells that give you the convective recharge field,
Okay.
right? So a single well pair, depending on the thickness of the aquifer, the permeability, and the temperature and stuff, will yield in the DJ Basin about 5 megawatts gross. Now, by gross, you're not thinking about the parasitic power that you need to
Sure.
run the pumps, if you need to, and the ORC systems. So after you kind of net all that stuff out, your net power is probably about 3.5 megawatts per well pair.
Which is in line with what you would get from, say, a conventional geothermal well.
That depends on the temperature of the water and the flow rate, but um, it's uh, it's in line with the ones that I know about.
Yeah.
and uh, and it's similar. What's interesting about what we're doing is we get to manage the plumbing system a bit more because it's in a sedimentary basin. We've got tools like seismic that can see what's going on. In a lot of the conventional systems I've looked at, the geology is very tortured and it's very hard to really see what that plumbing system looks like, right? I have a lot of uh, the folks that are making the conventional systems work are doing amazing stuff, right?
Yeah.
And so I think what we're trying to do is a little bit easier.
Yeah. That's very exciting.
So
Okay. Yeah.
the just to finish up on that, the size of the anomaly that we've been mapping in this one little area in the DJ Basin, we think it's somewhere around 200 to 250 megawatts for 30 years. So, and you scale these things up by drilling multiple well pairs
Sure.
and having them feed into a single power station.
Yeah. Fascinating. I'm super excited. Okay, I'm going to ask one last question. Um, are there any partnerships or collaborations that you guys are working on at GTI that are helping with your geothermal initiative?
Absolutely.
Okay.
So yeah, no, I probably shouldn't name names, but we're working with a very large oil field service business that's helping us with lots of aspects from the completions to minimizing the parasitic cost of pumping. We're working with a great group above the ground who build ORC systems, and they're really good at making power from thermal water. And we're working with a lot of smaller folks that help us with the 3D seismic data and re-looking at that for what we're looking for versus what it was originally looked for looking for oil. I mean, we're looking for, what sort of fracture systems should we expect? How do we stay away from the big faults so you don't get a short circuit and things like that. So we have a huge group of very accomplished geothermal and oil field folks that are helping us every step of the way.
That's awesome.
Yeah.
Well, Jim, I really want to thank you for joining me today, and I want to thank everyone else for listening in to this episode of Geothermal Unleashed. And I hope today's discussion has sparked new insights and deepened your understanding of the geothermal industry's incredible potential. Until next time, keep pushing the boundaries of what's possible, and let's continue working together to unleash the full potential of geothermal. Thank you, everyone.